What's up, guys? Welcome to Calculus Club. In this video, we will be talking about the squeeze theorem, often called the sandwich theorem. Okay? Let's get into it. All right, so let's ignore these three for a moment. All right, so let's take a look at this graph of G, F, and H. Okay? What you notice is that the graph of G, the graph of H, look like this, and the graph of F is always between the graphs of G and H. So we can say that F of X always lies between H and G. Okay? So the idea here is that if we take the limit, for example, as X approaches C, if the limit as X approaches C of G and H are the exact same value, right? Those two are indeed the exact same value, this value here, which is L. Okay, then we can also say that the limit as X approaches C of F of X is also going to be equal to L because F is always between G and H or equal to G and H as it is at L. Okay, so this will most commonly be used when trying to find a trigonometric limit. Let's do an example problem. So let's say that I want to find the limit as X approaches 0 of X squared times sine of 1 over X. All right, well, the first step that you always want to follow, that you want to try, is direct substitution, okay? So we try to plug in the 0 for my x, which that's fine, 0 squared, but then I get sine of 1 over 0. Mathematical error, right? I can never have a 0 in the denominator. So we need to do some more work to try to figure out if this limit exists, okay? Now, the way to do this is to realize that the graph of sine of 1 over x is always between -1 and 1, all right? So I hope you agree, before I say that, I hope you agree that the graph of sine, right? The graph of sine x is always between -1 and 1, right? It's just that the wave function, where the bottom is -1, the top is 1, right? So now, don't be confused by the fact that it's sine of 1 over x. Like, imagine that it's -1. The sine of any value a, the sine of a is always between -1 and 1. It doesn't matter what a is. So it doesn't matter that I put 1 over x in place of a or in place of x, right? The sine of anything is always between -1 and 1. All right? So now that we've established that, the next thing we can do is we can multiply everything by x squared. So I'll multiply the left, the right, the middle by x squared. So we multiply everything by x squared and we will get -x squared is less than or equal to x squared times sine of 1 over x, less than or equal to x squared. Okay, so now we have bounded, we have squeezed our function between two functions that we can solve for. And now what we're going to do is we are going to find the limit as x approaches 0 of x squared, and we're going to find the limit as x approaches 0 of -x squared, okay? So go ahead and pause the video and try these. All right, I hope you tried these. These are pretty easy, right? The limit as x approaches 0 of x squared is simply 0. The limit as x approaches 0 of -x squared is just -0, which is just 0, all right? And because we know that this function is squeezed between these two, right? So therefore we know that the limit as x approaches 0 of x squared times sine of 1 over x will also be 0, okay? And I'll show you a picture of this. This green is your x squared function. The limit as x approaches 0 we see is clearly 0, okay? The blue is your -x squared. Again, the limit as x approaches 0 is clearly 0. And then the red, now the red will have a hole here, right? X squared sine over 1 over x is discontinuous, but the limit does equal to 0 as well because you have squeezed it, you have sandwiched it between those two functions. All right? So yeah, so that's all for the squeeze or sandwich theorem. Mostly used when you have a trigonometric identity limit that you're unable to solve. All right, thanks for watching, and I hope you tune in to the next one. Bye-bye.